Good evening, everyone. Welcome to the 20th episode of Great Conversations and Talks. I'm Yashalika Rajshekar, currently pursuing my second year at GCT. It's my immense pleasure to introduce today's speaker, Ms.Rukmani Gopalan, an alumna of GCT, batch of 1999. I extend my warm welcome to our eminent guest speaker and all the participants of our webinar. Ms. Rukmani Gopalan is the Principal Program Manager in the ASU Data Lake Storage team. She is an experienced product manager with deep technical skills and over 15 years of experience shipping a variety of products ranging from mobile and desktop client applications to large scale enterprise grade services and platforms. Today, she'll be speaking on the topic Introduction to Big Data Analytics. It's our honor to have you here, ma'am. Before moving on to the webinar, we have some ground rules. If the participants have any queries or questions, please use the chat box. With this, I hand over the session to you.
Thank you so much, Yash. And thank you so much to Pradeep and Shakti who are organizing this GCT talks. Before I start talking about big data analytics, I really want to give a huge shout out to these folks because they have just made this so easy for us with enough notice and very clear instructions. So big thank you and shout out to the organizers of this. And to everyone on the call, great to meet you all. You know, GCT always has a very special place in my heart and pretty much all the classmates I know as well. So it's great to be talking to this audience who have this wonderful connection with a GCT college in Coimbatore, and it just takes me back to those days. Today, I'm here to talk about an introduction to big data analytics. Pradeep told me that there is a variety of audience on this call. We have students, we have people who are already working. So I have more of catered this talk to people thinking about a career and thinking about how to prepare for their options. So happy to talk about any other depth or length as is needed in the discussions. But today, what I'm going to be doing is giving you an overview of big data analytics, how to think about a career in big data analytics, and why is this such an important field that's full of opportunities. And we'll also talk about like various roles and options and resources that can help you get a good head start. Having said that, as Yash said, I work for Microsoft Corporation. So a few disclaimers that I would like to get out of the way. Any content that I talk about in this talk is my opinion. It doesn't represent my employers. And any names and references of customers or technology, I have used pretty much anything that's available publicly on the internet. So there is no information that I am leaking through this talk. So I just want to get that out of the way. And one more thing I just wanted you to be aware of is I tried turning my video a couple of times as we were getting ready for this event, and it always made my Zoom hang. So I'm going to give this talk with my video off. So thank you for understanding and for your flexibility. And I was just chuckling to myself because Yash said, I have deep technical skills and here I am. I did not know how to debug a camera turning on and off in Zoom and what was going wrong there. But hey, such is technology, right? So yeah, thanks for bearing with that. And once the presentation is over, I'm going to experiment turning my camera on again for the discussion and anything else. So without further ado, let's get into the world of big data. Okay, so I have three pictures here, which are not quite connected to each other. There is a FedEx package. There is Starbucks coffee, fill it with a beverage of your choice. And there is Myntra, a really popular website for shopping. What do you think these three have in common? And why did I even start this big data presentation with these three random pictures? Let me tell you a story. FedEx, as you all probably know already, is a famous packaging and shipping service. And FedEx scans about 16 million packages every day. And these 16 million packages could contain like Christmas presents or, care packages to loved ones, very critical life-saving medicines, and whatnot. And it's so important for a company like FedEx to ensure that they're able to deliver their packages with utmost care and guarantee their delivery, while at the same time making sure that they're able to make an optimized model to plan their shipping and tracking routes based on the various sources and destinations of packages. So back to GCT days, if you have learned this thing called a traveling salesman problem, FedEx is basically a living and breathing example of the application of this traveling salesman problem in real life. So as I said, FedEx scans about 16 million packages every day, and it on average, and each of these packages are scanned about 12 times before they go from the source to the destination. So think about all of these scans and the data and visibility to the customers, right? So if you have ever used a FedEx tracking, you click a link and it tells you exactly where those packages are and whether it has reached the destination or not. Where does all that happen? It all happens with data. And the kind of scale that we are talking about is 16 million times 12 per day. Those many events are sent by FedEx alone. And this kind of data is what gives the visibility to FedEx customers, which is just you and me, trying to know where our packages are. And it also gives visibility to FedEx as a company to understand where those packages go, how long it took, and how they can optimize their trucks and driving routes to go optimize for these. Now, something strange happened last year. And we are in this pandemic times of COVID-19, and FedEx was the chosen provider to ship COVID vaccines. It was even more critical now because these vaccines have a very limited shelf life. And if you don't scan these vaccines, if they're not delivered at a particular time, and while all through the delivery, a certain temperature condition is not maintained, then those vaccines are basically dumped in the garbage. And these life-changing vaccines that are on the cutting edge of innovation have a really, really critical dependency on this data that we just talked about. And not only that, now this dozen times is just not enough because, who knows what could happen? What if a truck breaks down? What if there is a traffic that's delaying the efforts? So FedEx basically increased these dozen scans to 300 sensors attached on the package that was emitting various information for these kind of very critical packages. Now, not just that, there is data that's coming from these packages. And what if the weather goes wrong? What if there is like a snowstorm? And as you know, the first of these deliveries began in the heart of winter in the United States. So what happens if some weather conditions delay these delivery of these medicines? And there are very critical people, especially we started with like the frontline workers and the people in very senior citizens. We wanted to make sure that these packages are reaching right on time. So all of this data gets analyzed in real time if there is a breakdown or if there is a weather condition. So FedEx can also take immediate action to go send other trucks or make backup plans so that these medicines reach on time. So that's story number one of a critical life-saving mission. Now, story number two, which is life-saving in its own way, which is, at least for me, because I live and thrive on coffee. Starbucks, which is a very famous consumer goods company serving coffee and other beverages and very delicious food to about, I think, if I'm right, about tens of thousands of stores, at least in the early 10,000 stores across the globe. We need to make sure that that coffee, there is a story behind how that coffee is made, right? So every morning, by the time we go and get our cup of coffee in Starbucks, there is a lot of things that happen behind the screen. So first, we need to make sure that all the right raw ingredients and materials like milk, the coffee powder, your bread and your sandwiches and cheese, all of these dairy oriented items, which are, which have a very small limited shelf life, they have to be planned and carefully executed in terms of how much order needs to happen and what what is the sales volume in each of the stores. And depending on those, you need to make sure that you are not ordering way too less so that you're saying no to customers. And you're not ordering way too much so that your raw materials are not wasted and your packaged food is not wasted. And then at the same time, if you see there is the Starbucks machines, right? Like these whole coffee machines. And these coffee machines are working throughout the day. So an average Starbucks store is open for at least 12 to 16 hours a day. And these machines are constantly at work. So how do you know if these machines break down? How do you know if these machines are working fine and they need their routine maintenance that's due that you have to go make it? Or they've reached their end of life so that you can go make a replacement order and replace these machines. Now, there is a third problem, which is, okay, this is all behind the screens. Now, Starbucks as a business has to go attract more and more consumers. And now the Starbucks has a wonderful app that basically tells you all your available promotions and offers. And you can go click on, use your Starbucks app to go place the order. And all you have to do, especially in the time of COVID, this was such a lifesaver for both the customer and the business, because you go place the order, the Starbucks store knows that you're coming, you go park your car right in front, and then they bring your coffee and orders right outside. And when and how does all of this happen? So again, from every step of the way, as they say, from farm to table, right from the coffee manufacturers and where do you go source the coffee beans to where do you go source the dairy, how are they transporting in time to these various Starbucks facilities where these are processed, and how do they get to the stores? How do they make sure that this coffee is being ground in the right machines? All the way to how are all of these translating to an excellent customer experience? There is data every step of the way. There are about 16 million Starbucks rewards members who use the app, and each of them receive very thoughtful recommendations about what kind of food and drink they can go add, depending on what your local store inventory is. What is your section? Like, are you a vegetarian? Then I will not bother showing you recommendations with meat options in it. Are you having like a low fat preference? So let me send you more healthy recommendations to your app. All of these, every step of the way, there is data involved. And all of this data is getting churned and analyzed in this huge infrastructure that's run by Starbucks, which is their central data platform, providing all of these amazing insights to Starbucks as well as to their customers. Let me finish my last story, which is Myntra. Myntra is basically a retail website that is relatively new, that has gained amazing popularity. And they have a portfolio of about 7 million styles from over 3,000 international and domestic brands that are available in the store. So think about the scale, right? How do you know? We all know that when we want to go buy, like say, our favorite kurta for Diwali, we want to make sure that that's available on the website. And this could be one of these 7 million styles. And Myntra as an organization has to go make sure that there is a right inventory. Again, very similar to you don't want to order too much, you don't want to order too less. All of this is possible by data. And very similar to what I talked about Starbucks, depending on if Myntra goes and has found a new provider or a new style, you want to make sure that the customer is aware of it by giving these thoughtful recommendations. And when you are going and shopping in your Myntra app or your website, you want to make sure that depending on your shopping preferences and shopping patterns, you are getting the right kind of promotions. Promotions are super critical for driving businesses in the e-commerce industry, and personalized recommendations. So again, every step of the way, there is data involved, and there needs to be made sense out of data. So why did I start my big data analytics presentation with these three very different but very powerful examples? In all these cases, whether it is packaged goods, whether it is a shipping service, whether it is coffee, or whether it is clothing, there is one thing that's common, because all of these businesses rely on data to drive their business. And all of these businesses rely on data to not just know about their customers, but also to actually transform what kind of offerings they can make and what kind of new products they can ship. And such is the proliferation of data. So a quick statistic in this context. There is a number 59. Do any of you know what this number stands for? So the total data in 2020 that was around was estimated to be 59 zettabytes. And this data is going to grow to 175 zettabytes by 2025. And for a very quick reference, 1 zettabyte is 1 followed by 21 zeros. It's that many number of bytes. That is kind of the data proliferation that we are talking about. And it is this kind of data that is continuing to drive pretty much every single business that you can think of or that you use on a day-by-day basis. And what is critically important is an infrastructure that is scaling to this kind of a data proliferation. So think about 59 to 175 zettabytes. You just don't need a system that can scale for this kind of data today, but you want to make sure that the system is elastic enough to grow to 175 zettabytes. You need that kind of an infrastructure to process the data. You need this kind of skill set to go be able to have people who can wrangle with this kind of data. And this data, as I told about, right, like it can come from anywhere. It can come from your, FedEx sensors that are sending like a few bytes at a time with the source and destination, just as, a set of a plain text file. This can come from like your very old industrial IoT systems where, they're just not having reliable internet and you just get random data at random times whenever there is internet connections. Or this data can be logs of your sales or your other systems. So the volume of the data is just so high, and so is the variety of the data, and so is the velocity of the data. So big data analytics is characterized by 3 V's: the volume, the variety, and the velocity. So what is becoming more and more popular is the reliance of businesses on this kind of completely wide variety of data that can come from anywhere at any speed. So the infrastructure to support it, the right skill set to go analyze this data and gain very valuable insights to present to the businesses to make informed decisions is all what big data analytics is about. So if you want to take away one thing from this talk, if anybody comes and asks you, what is big data analytics? The very one simple sentence is, it's taking any and all kind of data that can be completely random and wide in a spectrum of quality that it offers, and you will be able to translate it into high value insights. So low value data to high value insights. And imagine this at the scale that I talked about, which is the zeros will just keep growing to the right side. That is what big data analytics is. And that is what we're going to be talking about today. So I just wanted to call out, I won't be going through every single line item in this slide, but big data analytics is, as I said, we took 3 different industries and talked about the use cases. Pretty much every industry that you can think of today, whether it is manufacturing or retail or healthcare and life sciences, or the travel industry that's especially been very much hit by the pandemic, financial services, where the banks and insurance companies that they're looking at data, energy companies, especially energy and utilities, where you are thinking about a green earth and an environment conscious energy production. All of these very life-changing things are relying on data today. And this slide basically lists a very few set of use cases that are running on data. So I'll take one example that we haven't had a chance to talk about yet. Think about proactive health management. There are all these diagnostic devices, whether you go for your, scans or your blood reports. What happens is they all have an error margin. So you go once, they take your test, and there is a high chance, anywhere between a certain percentage, that result is wrong because the machine is faulty. they ask people to come back again. But you know how busy our lifestyles are and how, not everyone can afford this time to go to the doctor whenever they want. So a lot of people don't come back because of these faulty results to go take the test again, and then they just give up. And these folks, then if they have any of these critical diseases, they just don't have a way to diagnose these and be treated proactively. And then there are very, very severe consequences. The other thing, right, democratizing health. How do you know that if somebody goes in with a health condition, if it's your common cold or your, textbook diseases, there are treatments. But there are more and more complicated health complications that we are having the ability to detect. And how do you know that there is a condition that's detected in, say, Canada or Australia? Those lessons can be learned and applied to save lives in Africa. All of these, connecting different healthcare systems, connecting all the data and the different formats of and the compliance policies, because privacy is a huge thing where you just don't want to go publish all of this data on the World Wide Web. How do you take all of these lessons and translate into meaningful insights that can be life-changing? So these are all some of the initiatives that healthcare and life sciences is up to. Manufacturing, right? So when there are, these huge machinery, say some oil drills or, these huge industrial devices, a lot of things, a lot of these machinery have human errors or any small calibration differences in human errors that could cost like arms and legs of people. So how do you know, how can you train all these devices, gargantuan devices, to be more intelligent and have them provide signals where, they send these big, huge beeps when the unauthorized personnel is coming into that area or they're putting their hands or legs in the wrong places. So this can actually help a worker have their limbs working fine, in spite of working with these very huge machinery. As I know how many of you have seen Tamil movies where there are these, huge devices where somebody gets an electric shock and loses their limb. Data can prevent all of those diseases, all of those conditions. So those are some of the few applications. And this is why a career in big data is becoming more and more attractive. And there is a huge demand gap because, one, this data can be produced from now any and all devices, right? Your washing machine, your fridge, your sensor, everything is now capable of having some kind of sensors, some kind of, data transmitters to send data. Where does all this data go? How do you store all this data and how do you analyze all this data? And more importantly, what do you do with all that data and how do you translate it to all these meaningful insights? This is where the discipline of data analytics is growing. And this is where there is a wide variety of new and old job disciplines, right from, the old disciplines like software engineering or program management or product management, to the newer disciplines such as data scientist or machine learning engineer or data DevOps. So all of these spectrum of new careers are growing, and we'll see that in a while. But before that, I want to talk about, we talked a lot about the infrastructure and the higher level design. And one thing that I have learned, and I'm not sure this is exactly how we are taught in India to learn, it is not just important to know a technology. It is really important to understand the big picture of why we are solving certain things and how we are solving certain things. And if you start with the why and the how, the what becomes very simple enough to learn. And that what or the specific technology keeps changing over time. But what you want to put in perspective is, what is a problem you're trying to solve? Who are you trying to solve it for? And what is the big picture? So let's spend some time talking about the big picture. So analytics by itself is not a very new field. Analytics has its own journey, and analytics has been around for a long time. Even when I am as old as a dinosaur, but even when I was young, we had all these people looking at, DBAs, and I don't know if you've heard of this Oracle DBAs, which was the hot career at that point. So analytics in its earlier form has been around for a while. And what we were always talking about was a very traditional data warehousing pipeline, where you have various databases serving their own application needs. So you always started with, what problem do I want to solve? So if I want to build a user management system, then I knew, oh, I need to have very highly structured data about the users, their demographics, their pay information, their geography information, their age, etc. Right? So you would go create a highly structured data, and these are typically called as operational databases. So think of it as, a huge log sheet, or your Excel sheet that is scaling to a lot more data, and it is sitting as a technology. So if you know SQL or databases that you probably learned in GCT already, these are your operational databases that are serving your applications. Now, when it comes to analytics, there are insights you can draw from these operational databases or your custom business applications. This data goes through a set of transformations and it gets loaded into a large enterprise data warehouse. So think of it as a huge warehouse for your data, right? Like imagine all these filing cabinets that you go and search for, like these files. All this data goes into your enterprise data warehouse. And depending on what insight that needs to be achieved, it undergoes another set of transformations, and it gets served to data marts, which are again other set of very specialized databases that can be feeding reports, or data analysts can analyze that and draw these cubes, which are, think of data as being modeled into different dimensions, so you can see a trend where one value affects the other value, and draw all these pretty graphs and other things. So this is how analytics was in its original form, probably, a couple of decades or so ago. And one of the key things to note here is, as I said, you always started with, hey, what problem do I want to solve? Let me go get that data, put it in a database, and that becomes my source. It's always highly structured data. So if you've heard your database principles of normalization and first normal form, second normal form, ACID guarantees, this data adhered to all of those principles. And then you had specialized data stores that served a specific purpose. So one data store will serve your applications. Another data store acts as your centralized data warehouse repository. The third data store serves your downstream business applications. So data kept getting copied back and forth across these different systems. There were errors associated with this. And also you have these specialized databases or data stores that ended up storing duplicate copies of the data, creating what we call as data silos. So a silo is basically a partition where a data in one silo is not very useful to the data in other silo, unless you take that data from this one silo and go put it in another silo. And that was kind of inhibiting the amount of insights that you can get out of the data. And it also had a lot of effort involving in moving in this data back and forth. And it also had a lot of cost associated with the duplicate copies of the data. Now, when we talk about these big data analytics, we typically talk about a data lake approach. And what a data lake approach is instead of starting with a business problem, you always start with the data first approach. And in a data first approach, you take data in any form it comes, right? It can be pictures or files. It can be like your social media feeds from Twitter or Facebook, or whatever the kids these days are using. It can be your age-old data from your LOB apps or your operational data stores, just like we saw in the previous data warehouse pipeline, or it could be these few bytes of information that's transmitted by IoT sensors. You take all this data, and step one is you never throw away things as useless. You always ingest this data in their raw natural form into a storage, which is, I've called out Azure Data Lake Storage as an example here. There are very many such object storages that support the storage of these unstructured data. You go take them and store them in the central repository called as a data lake. And now when you have a business problem to be solved, right? So now let us think about the business problem of, hey, when do my coffee machines need replacement? Then you have your coffee machine sending these IoT data from IoT's Internet of Things, by the way, your coffee machines are sending these bite sensors data, right? Saying, I'm functioning fine, I'm functioning fine, I'm functioning fine at this date and time. You take that data and you have it in your store. You also have your coffee machine order data, which is, hey, when did I order this coffee machine? When is my warranty due? When does my warranty expire? What kind of extended warranty is available? All of those are in your business apps. You take that data, and remember, because you started with the data first approach, this data is already inside your data lake. And now in a preparation phase, what you do is you take this data and you start applying a meaning to that data depending on the business problem you want to solve. And this is called a schema on demand. A schema is nothing but a description of the data, right? So you have, let's say, a few bytes transmitted by your coffee sensor. It's going to have, say, a text. I'm just simplifying this. Let's say it has a very simple text file that says the hey, I'm working, which is the signal, and the date and time that it came as a comma separated file. The preparation phase basically applies this understanding, saying, hey, for the file that came from here, I know that the first field was a signal and the second field was a date and time. You take that and apply a schema on demand, and you go and prepare the data. And at this point, you also take the opportunity to clean up the data. What if your sensor is sending like 1 million events a day, but 1,000 of them are malformed? You can either choose to fix them, you can either choose to discard them, or if the same data came twice, you can deduplicate them. You take this data to the cleaning stage and applying the schema on demand. And you can take this opportunity to also apply some optimizations. There are these more advanced formats, etc., that lend itself for future processing. That is called as the data prep phase. So you take the data in its normal form, it's already there for you. Then depending on the business question you want, or the very common set of business questions you want, you take and prepare the data to give it some shape and structure, right? Think about your raw data as Play-Doh or your clay that's just sitting there. And the prep phase is basically giving it some shape, building some arms and legs and hands and head. And then you have the curation phase where you are generating the high value insights. So you are taking the data that you took from these coffee machines, you're taking your order data, you're combining these two and saying, hey, you know what? This coffee machine that I got 10 years ago, which was working fine up until last month, is now starting to show signs of degradation. I used to get like 10,000 healthy heartbeats up until last month, but now I'm getting only 8,000. So maybe I need to go do something about it. I need to go check it. Or if I'm getting 0 heartbeats, can I look at my warranty and go replace it? So all that clay that you made your hands and legs out of in the prep phase is now giving shape into a structure, where it could be like an elephant, or it could be a human, or it could be a rabbit. So that is your curation phase. That is your high value insights. And the final phase is the consumption phase, where if it is an elephant, then the elephant trainer is going to go take some action managing that elephant. Or if it is a rabbit, then you're going to go have like a pet farm take care of this. So the consumption phase is where your key business decision makers have the visibility in terms of what is the next action to take, and they are able to take corrective action. So in the case of the coffee machine, now if you see that there is a machine showing degradation, then you have the consumption phase sending a note to the application, to the the barista of your coffee house, saying, hey, can you check this machine? Is everything okay there? Did it require a cleaning that you made, or do you have to go order a different machine? Let me know. So that is your meaningful action. So very contrary to your data warehousing approach, where you always had very structured data that you created based on a business problem, where you started with the business problem first, and then you ended it, then you got insights from kind of the structure you created. A data lake approach gives you a very big spectrum of flexibility in terms of what kind of problems you can answer. And that is highly responsible for the proliferation of this data inside all of these businesses. Now, extending this coffee example, now you can say, hey, actually, I have all this coffee that seems to run fine, but in hot summer days, where I'm correlating with a completely different data set, which is the weather data, where I can correlate with the temperature and say, oh, in hot summer days, they tend to run hot and degrade faster than winter days. So I need to make sure that when I'm ordering and planning for the life of my coffee machine, I'm not just taking into account who the manufacturer is and what the signals from the data are. Now I can start correlating with the weather data and understand, hey, how my usage patterns will change between summer and winter and how much life I can get out of this machine. So the possibilities are endless. So that is how a data lake approach works. And when you talk about a career in big data, where we will go next, you can see that the career options fall under one or more of these buckets of your storage, your ingest, your preparation, curation, or consumption. Now, in that context, let's think about why is it important to think about a career in big data. So as I said, hopefully by now you get a really good picture of what is possible with big data and where is big data headed. And we have seen a very big proliferation. I myself have been working in this big data analytics field, kind of, either adjacent or playing one of the different roles for the past 5-6 years. And one thing I can tell you is 6 years ago, I was talking to a lot of customers about what is big data, why is it important, why do you think about big data as helpful to your business? Like, this was the nature of my conversation 6 years ago. And now when I talk to these key business decision makers who are, not necessarily software people, they come and ask me, right, which is, hey, how do I get all this value? I already had the cost of my operations reduced by 20%. How do I take this to even 50%? Or how do I take this to go invest in a new product? Or how do I go expand? How do I go use this data to figure out my expansion plan? So it's not about the why big data, it's about the how. And that is the beauty of big data analytics, because there is a set of technologies and fields that have gotten to a certain level of maturity that it is a very predictable operation, but that is not the end. There is still a whole bunch of opportunities that data is going to unlock. And there is a whole new set of skills that's going to start opening up. That growth curve is real. So Sheryl Sandberg once said, right, like, you get a seat on the rocket ship. Don't ask where you're going. Just get a seat and then go take the journey. And that's exactly what is happening in the field of big data analytics. It is a rocket ship. People understand it's a rocket ship. Where it will go in the next 5 years, we have a reasonable idea depending on how much we know, but who can say, right? Where is the next big disruption coming into play? So a few statistics. About 8 to 10,000 jobs are posted every month in big data career opportunities. You have, if you think about data science as a discipline, and we'll talk about what data science is in a while, data science, which is basically, thinking about your experimental, exploratory analytics, bringing patterns that a human eye cannot perceive, that has grown 650% since 2012. And this would mean growing this trend and the projected increase that in another 14 years, there will be 11.5 million new jobs posted. And when we talk about the infrastructure to manage and wrangle all this data, there is an accelerated growth on this cloud and edge computing, which is basically, lets you get out of this business of managing your own hardware and letting somebody else manage it for you, which are all these amazing cloud providers. There is an accelerated growth on cloud and edge computing that's gaining popularity as well. So while the whole data and the data wrangling business is growing, so is the business of growing the infrastructure that supports all this data and its associated options. Now, I added a trend in terms of where I said, right, like this is a rocket ship, who knows where it's going. Gartner is a very, reputable source in terms of they analyze a lot of customer trends and a lot of customer data. And they have predicted 3 trends that is accelerating in 2021, which is AI and data growth in terms of how they accelerate change is going to be the focus in 2021, which is how do you make artificial intelligence more smart and responsible? How do you take all these different pieces that we talked about, right? Like composable data and analytics. There's a whole set of problem space associated with the ingest. How do you get clay and put it in the data lake store? There's a whole set of problems associated with the prep phase, which is, hey, how do I wrangle all this data that's completely of different formats? How do I make it, into this Play-Doh in terms of, building these hands and legs? There is a whole different space according to that. Then there is a whole different set of technologies and problems associated with the curation and consumption. And then there are also more horizontal things going, right? Which is suddenly an enterprise that has data to deal with. Every single information about that business is now in the data store. So how do you know? How do you manage access? How do you even know what data is there? How do you catalog and how do you discover the data? And how do you ensure that the right people get right access, right? So the person who is analyzing sales data does not have access to the employee payroll, which might be important for your HR department to make sure how the morale of your employees are. There is a whole set of technologies, problems, and solutions in the data governance space. So that is something that is growing in popularity as well. And the other one is operationalizing. As I said, right? Like, do you really need to wait 3 months for your insights? Not really. As I said, when we talked about this FedEx example, you had to make decisions then and there. The sooner you know about the problem, the sooner you take action, the better your impact is. So data is going to become a lot operationalized. And XOps, which is merging a lot of your operational processes with data integrated into them and incorporating data into the intelligent decision making of your businesses, that kind of operationalization is very nascent still. That is going to be a field. And distributed everything, right? So in terms of your data is now not just on the cloud. Some data is on the cloud, some data is there sitting in your machines, some data is there in the edge. For those of you who don't know what edge is, think of edge as hardware that is there in your environment, which is your company or your school. It does not have a connection always to the internet, but it has some connection to the internet that basically can send you bursts of insights every now and then. So you can start making some intelligent decisions without even going to the internet, right on your system. And then when you have connection to the internet, you can go bring more knowledge to make more informed decisions. So this whole idea of cloud and edge and thinking about data where it is distributed everywhere and gaining insights, and more importantly, how do you actually have all these insights? You can actually make money now. So for example, if say in the industrial IoT case where I said, in the example of a coffee shop where I said, hey, Starbucks has all these insights about how often a coffee machine is going to be, having a shelf life for, what is the weather pattern doing with it. Now, Starbucks can actually start thinking about selling this data back to the coffee machine consumer. So data is not just helping you drive your business, but you can also make money of this insights that you get. And that is becoming a whole new popular field, which is how do I, have a data marketplace in terms of how do I sell the data and insights that I have back in a very responsible fashion to help other businesses as well. So all of these are very nascent fields that are barely touched, while you have your basic patterns of data lake architecture that has gotten a lot of maturity. So this is an area of a short growth. Now let's think about what are the different options that you have when you think about a career in big data analytics. You have one of two paths. So one, if you are a very, you can go build one of these analytics technologies and software that help other businesses. So we talked about, as I said, right, like your ingestion path or your curation path or your consumption path. You can go build one of these technologies. So you serve more than one customer, more than one business. You can go and you can go lead the disruption in how these technologies and software will make things easy for your customers. Or you can have core big data careers where you consume these analytics technologies to transform your enterprise. So think of the first one as you build a technology. You can have like your manufacturing or retail or anybody using that. You have customers, different customers using that. And the second one, you're consuming those technologies and you're making your business better. So you can take one of these two options. Each of these have very different roles. So in the first option of building your analytics technologies and software, You have a wide variety of category of products, and both of these can be either on the cloud or on-prem or on the edge. So without making any of those distinctions, you can work on, say, infrastructure products. Hey, I need some computers, I need some storage, and I need connectivity, right? Like, so compute, storage, and networking are the basic fundamental building blocks of your infrastructure. So one option is, how do you go build all of these? How do you make sure that remote hospital in the corner of Africa can gain valuable insights by establishing connections with others? How do you go ensure that they have the right set of computing resources or storage resources to go make your data-driven decisions? That is one area. So if you are a very fundamental operating system driven person, you like building these data centers and bit mapping, and you look at very low level problems, your infrastructure products are very exciting for you. And the short areas that you can start thinking about a career opportunity is in cloud services. So whether it is Azure or AWS, so infrastructure services never go out of business. The second area is data platform offerings, where you have more intelligent logic. So these are things where you have SQL, or the product I work on, Azure Data Lake Storage, or Databricks or Snowflake, which are products that sit on top of this infrastructure, but they make your life easy, where they give you a robust storage solution that we handle all the scaling and everything, where you can go and just consume it to develop your end-to-end application. Or if it's a SQL server, we give you a storage for structured data, and we also give you a query language, so you can go start querying, executing queries, but you still have a development muscle to go execute these SQL queries and optimize these queries and all that. The last one is software as a service offering, which is, how do you take all of these data and insights and make them very consumable? So this is more of building products that can be directly consumed as is, right? So for an example, if you've heard of like Power BI or Tableau, you can go connect to a data source and you can get all these pretty charts that you can construct by pulling different values. Or, my favorite product, Microsoft Excel, is a fantastic software as a service data analytics tool, where you can get data into it. You can go draw these pretty trends and graphs, wrangle data. These are all software service offerings. So if you are interested in a very core software engineering career, whether it is software development or your product management or program management, you can think about working on one of these areas of infrastructure, platform, or software as a service offerings as a career option. The other, think about career, as I said, consuming these technologies and bringing great insights to your business. Those are the core big data careers. There are different disciplines here as well. You have a data engineer career, where you think about, we talked about these ingestion, preparation, and curation. You will be responsible for all of this for your organization. So you'll use the different technologies and tools. Sometimes you'll have to fill gaps by writing your own code. And basically you get all the data and make it consumable for your data analyst or data scientist. So what is a data analyst? A data analyst is going to take these highly curated data, and they're going to provide insights to the decision makers. So if you are thinking about, even this LinkedIn trends or LinkedIn fields where you say, hey, I got 5,000 likes for this post, and I have 20,000 Instagram followers, and this topic creates a buzz in this trend, and this hashtag creates this trend. So those kind of insights are drawn by data analysts. They have a different set of tools that they work on. They prepare excellent dashboards and reports that can be used by your key business decision makers, which is your CEO or your website owner, right? Like, what kind of things attract customers? What kind of things are problematic? What are the top problems we need to go fix? All of these are kinds of data that your data analysts will research, provide the trends in the dashboard so that you can make very meaningful decisions. You also have a data scientist who is more, think about, this is your classic find your needle in a haystack kind of a situation. You have a whole bunch of data around you. A data analyst will work on kind of the known, the analogy that I drew. You've kind of made a human form or an elephant or a rabbit out of your clay already, and the data analyst is working in that kind of a visibility. Your data scientist takes some clay, some limbs, some rabbits, and then they kind of figure out patterns. So they are very exploratory in nature. So if you are a very curious person, and if you're asking always, why, how many stars are there in the sky, or why is the sky blue, kind of a problem, think about solving those with data. And you have all kinds of data that is available for you already, that your data engineer has created. You have some dashboards that your data analyst has prepared, and you can go bring your own data sets. So you can think about, okay, hey, I like that data from, following this particular channel on Twitter. I'm going to go bring this data and analyze how my Twitter influencer influences the sales of my product, or things like that, right? So a data scientist is very curious. You're exploring data and you're gaining insights that are not straightforward or intuitive. So a classic example is websites, right? So I have no idea still why this happens, but changing your background color from blue to orange could generate 10,000 more consumers. Or because you changed your font from say Sego UI to Calibri, you could lose 10,000 customers. And these are all not just things that are perceptible to our human brain, but these are things and insights that your computer can tell you. And you can conduct experiments to say, I'm going to send 50% of my customers will see blue, 50% of my customers will see red. How do I know what has more popularity? So these kind of experimental procedures are what data scientists do. And the last career, which is again very sophisticated, is architecting these end-to-end data platforms, right? As I said, what kind of technologies do you use? What is the pros and cons of technology? How do you stitch them all together end-to-end? How do I know what scenarios I want to get data analysts for and data scientists for? And when they come to you with requirements, how are you getting the data prepared in all of these concepts? How do you work with the data engineers to make the right things happen? How do you have the right set of governance, right? Like with the proliferation of data, as I said, with great power comes great responsibility. It also really is important for you to understand, hey, how do you guarantee the privacy of the people in your organization? How do you guarantee the privacy of your customers? How do you guarantee the data integrity of the data that which you make decisions upon? All of those are interesting problems that a data architect will solve. Last but not the least, I want to share some resources because, again, when I talk to people ad hoc about, these career options, not just big data in general, I always hear things like, Akka, how do I study this? And Akka, if I study Spark, will I get a job? One thing that I will say is, yes, definitely, it's always great that you're asking these questions. But as I said, focus on the what and the why and the big picture, and then use your technologies or your programming languages as tools to go make things happen. Some things that I want to call out for aspiring career people, which is not just for big data, for anything, there are many ways that you can start building your muscle now. The internet is far wide and open, and attend conferences. So most of these conferences, I've attached a few that are actually happening next week. There is Data and AI Summit, and there is Microsoft Build that's happening, I think, on May 24th to 27th. And the best part about this pandemic, all of these conferences have gone, mostly all of these conferences have gone virtual, and they have a free entry because now they can support a wider variety of audiences. They have a lot of interesting product announcements. Customers come and talk about their stories. There are trends. There are hands-on labs that are free. You get to network with other people who are solving similar problems, or there are mentoring opportunities. Some conferences also have recruiting. So attend these conferences, familiarize yourself. The first conference you attend you're probably going to be very overwhelmed. But the next conference you attend, you're going to know something, and then soon you get to navigate these words, and all of these words are not just strange for you. Most of these conferences also share their videos of the sessions on YouTube or on their websites. So highly suggest checking some of these out just to know what's happening around you. The second one, certifications. I am personally not a huge I wouldn't claim to have a huge knowledge in certifications myself. I know that it is a popular one. It's not an area I have explored, but they build expertise in a specific solution and give you a very structured learning environment. So you have a broken down agenda and you have a broken down syllabus for you to learn with very structured hands-on exercises. So that's another avenue that you can go explore. The third one, again, I highly encourage is attend meetups and hackathons. So now, again, with the wonderful connectedness that we have around us, there are all of these meetups and user groups and hackathons where you have challenges that are thrown at you that you can solve. And you not only learn a technology in this process, but you also think about how to solve problems. As you know, the careers of 2021 are less based upon skill set in a particular technology, but you are going to be having this core muscle to solve problems and exercise your critical thinking muscle. That is going to be more valuable because technology keeps changing and there is a whole bunch of technology, and it, as I said, it becomes a tool in your bag, right? So think about as a carpenter doesn't get a job because they know how to use a hammer or how to use a saw. They know how to build a table. Think about your career options like that. And hackathons give you a great way. Again, go look at your area in terms of what are some of the hackathons. I've attached a sample here. I don't even know what this is. I've not tried it, but these are examples, right? And especially you can trust the hackathons that are conducted by reputable institutes. So I think last year, for example, I think the NOAA, the Ocean Administration, gave a hackathon saying, I'm giving you all my data, go see what sense you can make out of it. So think about those kind of hackathons where you have the data already, you have some sandbox environments and tools that you can work with, you can start making progress there. So with that, I will end my presentation. Thank you so much for the opportunity.
And thank you, Rukmani. That was an amazing session, pretty interesting with all the resources. So we have a couple of questions coming up from the audience. So we have one. Let me just, talk out loud. So this one is from Mr. Chandramouli Venkateshan. He's from the batch of ENI 2001. So he had a comment and also a question. So the comment that he has was, marketing is big and we collect clickstream data and every firm has challenge with driving journey analytics. That was his comment, is what I suppose. But there's a question also.
Okay.
Taking a data first approach is super critical. Talking to business users, I see that businesses complaining of lack of agility to solve their problem. What are your thoughts on the balance?
Okay, so let me understand your question. And I totally agree with you. Getting clickstream data and analyzing your journey analytics is very important. And I'm going to go look at the question, which is lack of agility to solve their problem. What is your thought on the balance? Yes, so exactly, right? So this is what I was telling you about, which is your data integrated into your life cycle. That's a very nascent technology. So right now, what you can think of is you have all these Lego blocks, right? You have the Lego blocks, and then you have to go construct your house, and then you might find that there is one small piece that's missing that you have to go fill the gaps yourself. And you might not find that, hey, the one Lego piece is from this set and another Lego piece is in that set. They don't attach well together. So those are kind of the problems in stitching together the end-to-end solution that impacts your agility, which is your speed to insight. Again, going back to the problem, think about the way I always like to solve problems, and this has helped me in the past, is think about what is the problem you're trying to solve. And there is a crawl, walk, and run approach. So what is a crawl, right? So for example, you are losing business in a certain area and you don't know why. It's better to go focus on that aspect first instead of a broad brush understanding of, hey, I want to know everything that's happening with my business. So going after these specific problems and nailing your solution is always a good approach that works. I completely agree that this is something that is not very straightforward, depending on the situation that you're in. And when you are thinking about, say, marketing analytics or clickstream analytics, there are existing solutions that you want to explore as well. So there are existing solutions like Mixpanel or other things that tell you when you have a website, you can go attach your Mixpanel to that, and then it gives you automatic insights on how your clickstream trend is going for that website. So is that something that you want to look at? Or if you're looking at customer engagement and customer insights in terms of what kind of users are coming and what kind of people are coming, you can take again the Lego block approach, or there are other other solutions, like there is customer data platform, customer insights. There are all these customer data and customer, which are very focused on this understanding of your customers, and that can drive your marketing campaigns. So Microsoft recently has this product called Customer Insights, right? Which is exactly done to simplify this problem. So there is again no silver bullet in terms of, hey, we've solved this problem. You can start using, plugging it and chugging at it right away. But there are ways that you can go, once you understand what is the big problem that you want to solve, what is the most critical problem you want to solve, what is coming along your way to stop progress there. Can some of these existing tools be used to address while you bake your larger solution? Or can you have developers to go address the small gap to build the solution? Raising that kind of visibility to your leadership is always important, because then you can get the resources that you want to go solve that problem. I hope that helps, or I don't know if that was the intent of your question, and would love to hear more.
Okay, thanks, Rukmani. That was insightful, and we are also posting a feedback form, so wherein the people can reach out to you with additional follow-up questions. So we're going to post that in the YouTube chat. So who is having additional questions, maybe they can follow. And we have some more questions coming up from the students.
Mm-hmm.
So most of the questions are like, what's the difference between data science and big data analyst? So we often hear this terminologies like, right, data science and data analytics, both are like, so what's the basic difference is what the students are asking.
Yeah, it's actually a fantastic question. So think about analyst, data science and data analyst. Again, you ask 10 people, you might get 10 responses, right? So I'll tell you my response. Data analyst is someone who is able to take data and show you trends. So if you see, like, CNN showing your pandemic graphs, or you see your election reports, the people who prepare those kind of reports from your data are data analysts. So as I said, they work on a pretty structured problem space. They have the data that they can work on, and their energy and muscle is spent on solving these well-defined problems and business questions by preparing some of these reports and dashboards. Data science is, again, very scientific. It's very exploratory. There is not a specific problem you're going to solve. You might be given a business problem at best. You might say, as I said in the previous example, hey, I'm not making enough money in this particular country. Go figure out what is happening. And at that point, the world is your oyster, right? You go get the data that you want. You ask for more data. You can bring your own data sets. And you can work on a whole bunch of these very simplified machine learning techniques that you use to explore your data, and you are generating insights that a human brain cannot perceive. So let's say the classic difference that I will say is, you sit and work for 1 month. You can probably put that chart together that a data analyst does, but you sit and work for 2 years, you're probably not going to connect the dots between two things that a data scientist can using some of these techniques. The big difference is you have your machine learning, which is a very integrated part of data scientist. So you have a lot of learning techniques that are either in your, there is supervised learning, right? Which is, think about Alexa and Siri and all these technologies where you have voice recognition. When I speak from my mouth in my own accent, how does this machine know what I'm talking about, and it's responding? So teaching all those techniques, or picking up patterns and clustering them together to gain valuable insights in an unsupervised learning. So all of these technologies and the technology products are tools in the tool bag of a data scientist, where they'll be used. Data scientists themselves very rarely build these machine learning techniques. Those are machine learning engineers. I didn't have a chance to cover that. That's probably a deep dive by its own field. But a data scientist will typically use some of these machine learning algorithms or machine learning APIs and libraries, and they will go build these trends in terms of what they will build. And a classic example is, I know how many of you follow sports here, who's going to win the next IPL, or how do I pick the next draft for my IPL team, or, how does my NFL team going to do? Those are things that a data scientist will solve.
Thanks, Rukmani. We have one last question so that we will wrap up the session. And I have also posted the form where the participant can pose their question. So let's wrap up with this last question. So this is Mano Prakash, a batch of 2009 BE CSE. In the recent days, the Indian healthcare data is getting organized. On what ways the big data analytics can help in the Indian healthcare?
Hey, great question, guys. I am going to stick to what I know. I am unfortunately not very familiar with the Indian healthcare system, but let me tell you a little bit about the United States healthcare system and some of the problems that we are facing. Most of that might probably be a reasonable translation to the Indian healthcare system. So in the United States healthcare system, it's a very interesting space, right? Because as you know, United States is a country, but every single state has its own laws. And then there are national laws and the federal laws at the countrywide level. And each of these have a very unique combination in terms of what is acceptable and not acceptable for each of the pockets of this country. And from a technology choice perspective, each state or each city or county or each hospital from a private standpoint can go choose how they can get and store their data. Roughly, I want to say about 10 or 12 years ago is when the digitization effort began in the healthcare industry in US, because before that, everything was in paper, right? Like paper and files and ledgers. And there was a very screaming need that this was not scalable to identifying some of these key patterns. And there was a huge step that we took in terms of taking these digitization as a mandate where everybody started making this conscious effort. And the primary reason this was a huge deal was because we had to do it in such a way that the privacy of the patients are respected. So in US, the privacy laws are way higher than India. So for example, in India, if I fall sick and I'm unconscious, the doctor can tell my parents or my husband what is going on with me, right? And in US, it's not very straightforward. Like that patient, before they go unconscious, should authorize saying, hey, my medical history can be shared with my husband, and those kind of things. So it is a very different ball game. And this privacy is one of the very key things that we have to offer as a guarantee as we are thinking about some of this digitization in healthcare. So as we are thinking about big data analytics, having said that, the first step, which is going to be very challenging, is how do you take all these very disparate ways of diagnosis and measuring and even your lab results? It can all come in different ways and forms. How do you take that and centralize it in terms of a single source of truth, right? And that single source of truth doesn't mean all data is in one place, but think of it as a logical truth depending on data in different places, while maintaining the same security and privacy guarantees so that your results are not posted on the public web, right? Which means, if somebody has cancer, you don't want to go that, you don't want to be able to go do a Google search and find that out. So that's problem number one, which is the whole data wrangling and understanding and getting it into a common form. The second one, which is very interesting, is, as I said, hospital one has an insight. There is only some information that they can share, because if you share too much, then you know that you will be able to trace it back to that person. Especially think of this for rare medical conditions, right? How do you think, there is a rare medical condition for a woman in her 40s living in Seattle, Washington, who is of Indian descent? It doesn't take much reverse engineering to figure out it's me. Now, how do you take that kind of knowledge, however, and say, hey, I do think that Indian women in their 40s tend to have this condition that can be prevented by this proactive medicine. So that is a very classic data science problem that can be solved with data. There are a lot of healthcare startups that are onto this method. There are startups like, I don't know how many of you have heard of this 23andMe, which has completely democratized detection of genetic disorders based on, you had to go to the lab and you have to go, not everybody has expertise. And now you just take a health swab, you take a swab out of your mouth, send your saliva sample to your, mail it in a packet, and then you get a report back. So again, simplifying some of these detection mechanisms are another way where your big data analytics can help. And now now, especially now, COVID-19 is top of everybody's mind, right? How do you control the spread of these diseases? How do you think about these new variants, and how do you get ahead in terms of testing some of these vaccines and other things against these variants? You can't experiment with humans, you can't experiment with rats at the scale. You have to go create some simulation models, and you have to go package some of these into repeatable processes. As the moment you get a new signal, how do you get new insights on where the disease detection is going? So that are some of the areas where I see healthcare industry applications of big data analytics. As I said, I will let the experts tell me how and what of these subsets transform to Indian healthcare system. But it's a long journey, that much I'll tell you.
Yeah, definitely. Yeah, that's a long journey. And I think this is just the beginning. So let's wrap up the session. I would like to call upon Sundar Ganesh to provide the vote of thanks. Sundar Ganesh, over to you.
Thank you. I'm honored to have the opportunity to propose the vote of thanks today. First and foremost, I would like to thank Ms.Rukmani Gopalan. Thank you, ma'am, for giving a guest on the big data analysis and AI. The details you have provided are so insightful and amazing. Secondly, I would like to thank our honorable principal, Dr. P. Tamare, ma'am, and respected Dr. V. Prasamuji, sir, Secretary of the GCT Alumni Association, and all the participants of our webinar. I would like to thank organizing team for putting the effort to for this wonderful talk. Thank you once again.